Okay, guys, we're going to do 8.1 today. Some of you have some credit in 8.1 already, and that's because of the knowledge check we did in January. So, I figured out a nifty way to display the problems, so I can actually click on them now. So, let's find 8.1. Okay. Whoa. I want that to go away. So, we have four definitions. Lines that belong to the same plane and never intersect. Is it possible to have two lines that are drawn on the same piece of paper and they never touch? Yes. What do we call those lines? They're parallel. So these two lines are parallel. So, having exactly the same shape and size. So if we have two triangles and they are exactly the same shape and exactly the same size, what do we call those? Congruent. Good. The set of all points in a plane that lie the same distance from a single point in the plane. So what that means is you have a point, and then you draw every point that is the same distance from that point. So you have to have a distance. Let's say that's my distance. What would the shape look like if, let's say this is 2 feet. What would the shape look like if I graphed every point that is exactly 2 feet from that point? So I could go out 2 feet and put a point. If I go out 2 feet in a different direction and put a point, 2 feet in another direction, and if I did that for every possible point, what's going to happen? We're going to get a circle. Okay? All right. Belonging to the same line. Collinear. So collinear would mean points on the same line. Now let's go through these others because it'll probably ask you more about them. The top one says coplanar. What does that mean? On the same plane. So if I were to draw 3 dots on the floor, the janitors would probably be mad at me. But those 3 points are coplanar. Okay. Perpendicular lines. What does that mean? What does it mean to be perpendicular? Miranda's calling for timeout. 90 degrees. The two lines that meet at a right angle. Okay. What is a line segment? Yes. What's the difference between a line and a line segment? Right. Line segments have a start and an end. Lines go forever in both directions. What if we have one that starts and then goes forever in one direction? It's called a ray. Okay? And then what is an angle? Miranda's really good at hand gesturing. So this is an angle, right? How do we define that? Oh, so we could call it acute, right, or obtuse. So there are lots of ways to define angle, but in this case, I used 2 segments. So it's the structure that's formed when 2 segments meet at a vertex. Now, does it have to be segments? No, they could be rays, so it could look like this. Do they have to be rays? No, they could be lines, in which case we actually create 4 angles. Okay? Oh, good job, Miranda. Okay, let's look at the next. So in this figure, make sure that you understand what it's saying. Those 4 points are on plane X. So we have a piece of paper and we have a line. E, F, and C are on the same line. And then we have a line that contains B, C, and D that goes through the piece of paper. Okay, so letter A asks, B and what other 2 points are collinear? B, C, and D. Okay. Line FC and what line are distinct lines that intersect? So FC would be this one. What's the name of the line that intersects it? It could be BD or BC or DC or CD or CB. There are lots of options. Okay. All right. E, blank, blank, and blank are all coplanar. Complainers. So E and F, C, and A. Okay. And then another name for plane X is plane. So we can use a letter as the name of the plane. How else can we name a plane? Not all of them, because there might be 100. Right? How many points does it take to name a line? 2. So how many do you think it's going to take to name a plane? 3. So here's the theory behind that. If I have 1 point, how many lines are there that touch that point? An infinite number, right? How many lines can I draw that hit that point? An infinite number. But if I put a second point, now how many lines hit both points? Only 1. That's why it takes 2 points to delineate a line. Okay? How many planes hit those points? An infinite number. Let's see if I can make sense of it. So this piece of... Oh, I deleted it. That piece of paper hits the plane, right? Or hits those lines. But so does this one. And so does this one. And so does this one. So if I add 1 more point, so if I add a point like out here, now there is only 1 piece of paper that hits all 3 points. So if you say plane and then name 3 points, you have created a unique plane. So a line takes 2, a plane takes 3. Okay. Okay. Classify each figure as a line, array, or a segment. Oh, that's pretty easy. So make sure you use the correct structure, and then you state what it is, and then it doesn't matter if you call it ray KJ or ray JK. Actually, array does matter. Sorry. Lines don't matter, segments don't matter, but rays do because they're one-sided. So ray, if you do it in this direction, has to be JK. All right. Get to work, guys.